This presentation concerns the valuation of plant and machinery. More generally, we'll be looking at chattel valuation, because what we're going to find is that plant and machinery valuation has to do with the valuation of personal property. That is, anything which is not real property, and in fact that's the operational part of the definition. There are a number of different terms for personal property. Plant and machinery is simply the industrial side of personal property. The general term are chattels. Another term is personal property or personalty, or even movable property. All of these things refer to things that people own that are not related to land. Most of the chattels that valuers are called upon to value have to do with income-producing chattels, which in accounting are referred to as assets. Generally, the definition of plant and machinery, or in fact chattels, movable property, personal property, is that it's anything movable, anything that is not secured to property. And in earlier and simpler times, personal property, say, associated with real estate, was considered to be those inclusions in the property that were not physically or permanently attached. And so if you had something like a bookshelf, that was considered to be personal property so long as it was sitting on the floor. But once you screwed it to the wall, not even to keep it off the floor, but simply to stop it from falling over, it became a part of the building. And this was an advantage for landlords when tenants would come along and perhaps screw a bookshelf onto the wall, and suddenly it became the landlord's property because it was part of the real property. So chattels, personal property, are movable property. They're not secured. In more recent times, plant and machinery has stretched the definition somewhat, because a lot of plant and machinery does require some kind of fairly secure connection to the ground. So large pieces of machinery, say lathes and so on, will be bolted onto a concrete plinth on the floor. Well, it's bolted down, and therefore it's part of the property? Well, not quite, because it's considered that in the industrial world it's normal for these things to be bolted down. However, that doesn't make them a part of the factory building. And so the distinction there between screwed down versus not screwed down is a little bit vague. Because it's relatively difficult to separate personal property from real property, we find that the definition is really for legal convenience, and so it's only a convention, and that is, it's an arbitrary rule which will change over time, or may change over time, and as a result of particular social or community needs. It is not a part of its fundamental nature. It's not a part of what we could call the metaphysical identity of property. And that leads to one of the curiosities. Valuers are often preoccupied with whether property is real or personal, because that's the legal definition. However, valuers sometimes have a real blind spot when it comes to understanding what property is. Now, this is really quite an anomaly when you consider that a valuer should be an expert on property, and yet valuers by and large haven't been educated or haven't really thought through the question of what property is. It might be a good idea for us at this point to actually ask that question. What is property? This leads us back ultimately to a philosophical question, and so it's good to start squarely with the philosophy of property. The first thing we find is that the word property is actually a philosophical term primarily. The property of a thing is a quality that the thing must have in order to be itself. So, for instance, the Sydney Harbour Bridge must be in Sydney, otherwise it wouldn't be the Sydney Harbour Bridge. Okay, so if you find a bridge which is in San Francisco or London or some other place, the one thing you know for sure is that it doesn't have that essential property of being the Sydney Harbour Bridge, and therefore it can't be the Sydney Harbour Bridge at all. In a more general term, we can look at the properties of other things. For instance, a motorbike. A motorbike has the essential property of having two wheels. If you see a vehicle going down the road, and it can be ridden by somebody with a helmet on and so on, but it's got three wheels, the one thing you know is that it's not a motorbike. We would call maybe that a trike. Water is another example which is commonly cited when talking about the notion of properties. Water is a colourless liquid that boils at 100 degrees Celsius at normal pressure. What this means is that if you find a liquid which is either not colourless or boils at a different temperature, then you know one thing for sure, that it isn't water. And the reason for that, quite simply, is that in order to be water, the thing must have the quality of being colourless and the second quality of boiling at 100 degrees Celsius. What this means is that the notion of property, at least as far as its connection with humans, is rather curious. Because if property for humans, human property, are those things which a human must have in order to be itself, then it's a bit problematic, because I can still be me if I lose my house or my factory or my block of home units or whatever real estate I might happen to own. And so the whole notion of why the philosophical notion of property should be applied to those things that we happen to own is curious. At another level, however, our properties, our real estate holdings, are things that enable us to live. And so we find that humans are the kind of creatures that can't live without some kind of access to space. We need space to live, to make our food, our clothing, our shelter, and to source our raw materials. And so one of the properties of being human is our need for access to space, a relationship with space. There's another aspect, though, and that is that the necessary connection is actually a connection that comes through our life. Let's look at how that relates to real and personal property. Real property cannot originate with the producer, and that's why I might have my property, which is my house, but I can sell that property and get another one. It's not intimately connected to me, and it certainly doesn't originate with me. I didn't make my house, or at least I certainly didn't make the land that it sits on. However, with personal property, and especially those things which come as a result of human activity, the property, the ownership, what we call the title, originates with the owner. And so what that means is that if I happen to own a painting, or maybe a song, or some other thing that someone's made, I might own a boomerang, and the boomerang was made by an Australian Aboriginal person. Well, who owns the boomerang? Well, the person who made it is the first owner. They own it merely because they've applied a part of themselves to making it, because they've spent some of the time, some of their own time, some of their life. They might have been sitting by the beach, but they've decided instead to be out somewhere with a knife or something carving away a piece of wood to make the boomerang. And so if a person owns their own life, then they own their own products. And so the Australian Aboriginal owns the time that they put into carving the boomerang, and so when the boomerang comes into existence, it is the property, the natural property of the Aboriginal owner. And when that Aboriginal owner then either gives it or sells it to somebody else, I might have it in my possession now, then that boomerang, then the title of it, the ownership, passes on to me. It becomes my property. And again, this ownership transfer of property is linked with the idea of natural title. And so it becomes my property. It's something proper to me. because in some ways I have some listed ownership. We won't go too far into that. But generally, the big problem there is that because we don't make land, we can't say that there's any essential root of ownership. There's no original ownership. And so real property is only ever conventionally owned. The ownership of property is only ever an arbitrary rule or a decision or a convention which is applied in a particular social arrangement. And so whereas the Australian Aboriginal might have his boomerang, which he can certainly know that he made it, he owns it, and there's no doubt about that. When Captain Cook arrived in Australia, he looked around at the land and he didn't think the Aboriginals owned the land at all, and so he decided that he would own it, and so we have lots and lots of problems. But we don't have that sort of problem with personal property. These essential issues of ownership are really quite key to the valuation. We find that chattel property, chattel ownership, is more closely related to the human labour that actually makes it up. And we'll find that as a result of that, the valuation of chattels tends to be more closely related to their cost of production than to their use value. But we're getting ahead of ourselves to talk about these things at this point. Let's now take a look at the sort of things that plant and machinery valuers are called upon to value. They are referred to as plant and machinery valuers because most of what they work with is plant and machinery. However, you will find that many of the things that PMM valuers value is actually well outside of what you will find in a factory or some kind of production facility. It includes really the full range of chattels. What I'm putting up on the screen here happens to be things that I have had personal experience in valuing one way or another. And you'll see that it does range from the industrial, predictable, property-related types of plant and machinery to some other rather curious and unusual things. And the reason is that chattel valuation can involve an extremely wide variety of things. We have the production line components and most of the equipment that you would likely to find inside a factory. So that would include plant and tools. There's also materials handling machinery. So that includes things like conveyor systems, hoists and cranes, trucks and other vehicles are important. You also find investment collectibles are often valued by plant and machinery specialists. And so things like fine wine, pieces of art, and so on will be valued by P&M valuers. Office equipment, so computer equipment, printers, IT equipment, medical instruments, scientific instruments, virtually anything that is not really well nailed down. I've even come across a plant machinery valuer who at one stage was called upon to value Aboriginal rock art, which was not considered to be real property, even though it was attached to some rather immovable rocks out in a remote part of Australia. And so plant machinery valuation covers a very wide range of objects. Now, despite the fact that plant and machinery valuation or chattel valuation covers an extremely wide range of objects, it still comes back to the three dominant methods of valuation that we've met elsewhere. And they are the market comparison method, which is the strongest, and one way or another we almost invariably are using market information even when we're using the other systems. Then comes the income method, and that relates primarily to the profit potential of an asset, excluding the business that the asset might be used in. This can also include the valuation of collectibles, say bottles of fine wine. They will be valued by a plant and machinery valuer in terms of their future value as a collectible, which is considered not in terms of the pleasure of drinking the wine, but rather in terms of the sale price that the wine might have at some point in the future. And so that is a one-off future income. And so we use the income method from time to time. Generally, the income method is not as common with plant and machinery, however. By contrast, the cost approach, which in real estate tends to be used only rather sparingly, finds common application in plant and machinery valuation, and especially working towards what is referred to as the depreciated replacement cost, or DRC. And we'll find that the depreciated replacement cost method also finds application in analysis of market comparables. And so we find that DRC becomes a very common part of the valuer's toolkit within plant and machinery valuation. Like real estate valuation, plant and machinery valuation is heavily influenced by the valuation purpose. The common purposes for plant and machinery valuation include financial reporting and taxation purposes, and this commonly requires a depreciated replacement cost, although not always. Another purpose is simply for sale, and their fair market value, FMV, is more likely to be required. However, the fair market value may be derived by looking at depreciated replacement cost or maybe an income method, depending on the asset and the circumstances. There are cases where legal compensation cases require valuation of plant and machinery. These can be in terms of fair market value or the deprival value. And this latter is especially the case in productive situations, say factories or mines, where the deprival of an item of plant and machinery may have considerably more impact on the business than its apparent fair market value. Valuation can be as part of a business and or as a specialist property. Now, perceptive students will notice if you've done rural valuation, there is already a component of plant and machinery type valuation often done as part of rural valuation. And that is when you work out the value of rural properties by adding together the various components that you find on the property. Some of those components, such as silos and so on, can be, well, virtually portable enough to be considered plant and machinery. And there are other specialist businesses, for instance, aquaculture, inland fish breeding, that might use significant plant and machinery, such as pump systems and so on, that also are a key to running the specialist property. Insurance is another purpose for valuation, and like real estate valuation for insurance purposes, insurance valuation is typically worked on either depreciated replacement cost or the total replacement cost reinstatement as new cost. And so you have to look at what the terms of the insurance are when you're looking at the purpose of valuation and the way that it's done. Unlike real estate, plant and machinery is movable, and that means that its value has a certain component related to where it is, where it needs to be in order to be sold or to find a market, and also often, especially to do with productive assets, there are issues related to the commissioning, in other words, the setting up of the plant and machinery. For instance, if you were to buy yourself a gantry crane, which is a very useful asset for many, many businesses, the crane itself might be able to be purchased, but to get it to operate, you need to set up a set of rails, a particular set of power supply arrangements, and probably a whole flooring arrangement suitable for the gantry crane. And so what this means is that the cost of having a operating gantry crane could be very different to the apparent cost of buying the thing. Let's move now to the consideration of valuation strategy. Again, there are many similarities with real estate valuation, which is one of the reasons why the better plant and machinery valuers tend to also have a background in property, although this is not always the case. A primary consideration is to consider the most probable buyer. And because plant and machinery valuation, like real estate valuation, is largely linked in the demand value for the object under consideration, the buyer is a critical part of the equations. The second element in terms of valuation strategy is the importance of learning the peculiarities of the market. We're going over a number of general concepts in this presentation, but this certainly won't equip you with the necessary experience to go out and value any particular piece of plant and machinery. And this is because you really have to understand the characteristics and peculiarities of the particular piece of plant machinery or channels or what have you that you're dealing with. You have to be willing to learn about how the people that use it and value it and trade it think about it and how they value it. For instance, if you're dealing with earth moving equipment, you'll be looking at the size and the capacity of the piece of equipment. You'll be looking at its logbooks to see what sort of work that it's done, what its maintenance is like, and especially how many hours of service. Now, if you're not aware that a buyer will look very critically at the hours of service and the service record, then as a valuer you won't be able to appropriately value it. And most other items of plant and machinery also have their own peculiarities. You have to learn what qualities the market is looking for and how the thing is considered in terms of its quality and appreciation especially. Third point, like real estate valuation, is to gather the data. You go out looking for as much information that you can find, hopefully to help you with the methods that you've selected to do the valuation. And partly from the data, partly from the type of asset, you need to select your primary method. For individual items, you need to look at the market and character. Often you'll be looking at comparing valuations for a large number of assets, especially for financial reporting purposes. And in that case, you'll be looking at asset registers, the lists that a business will keep of what assets are on their books. And that will include information related to age, original purchase cost, and so on. If you're valuing an asset register, you'll be very interested in understanding the way that the various items on the register depreciate. And this often means you will have to be able to consider what is the most appropriate form of depreciation to apply. And so plant and machinery valuation is critically influenced by a working understanding, a good working understanding of real depreciation, not simply the accountant's depreciation, which is normally used for taxation. After you've done all these things, you can select your check method or a secondary method. In all cases, your valuation strategy should align with the established standards, especially the IVS standard, but also the API has an Australian standard for plant and machinery. We've already suggested that plant and machinery is more aligned to cost considerations. What that means is the replacement cost new is the natural upper limit. If you're trying to sell somebody an excavator, you can't put a price on it which is above the new price, at least the new price to get it to whatever location they happen to be interested in using it for. It also means that plant and machinery valuation is implicitly linked to labour content, since the production of assets of any capital item is ultimately linked to its labour cost plus its raw materials. Collectibles are linked more specifically to demand, and so your bottles of wine or artworks and so on, they must be limited in supply. There's no point in trying to invest in cask wine or something where there's so much of it getting around that regardless of its quality, no one's going to pay a great deal. It needs to be something for which there is a demand and also limited supply. And this also links back to what we were saying in valuation theory, that one way or another, what makes valuation interesting tends to be the way that in practice most things that we buy and sell are bought and sold in environments which are at least approaching a micro monopoly situation, which means that pricing is done more by demand than by supply. We find that depreciation, the amount of wear and tear that is coming off the value of a thing, is one of the major mechanisms for comparing different assets. And this is because, again, staying with, say, an excavator example, if we have comparables of different ages and maybe different amounts of working life, different numbers of hours worked, depreciation will be the mechanism by which we'll be able to compare those apparently comparable assets of different age. The importance of depreciation for the plant and machinery valuer means that they have to have a good understanding of the way that depreciation works. Now, this is partly related to having good product knowledge and market knowledge, because it's understanding the product and the market which will give you an understanding of the character of the depreciation, the overall way that the product behaves over time. You also need to go to the market to get an understanding of depreciation behaviour. What are the habits in the market, the preferences that you find, even for assets that in some cases appear to have fairly similar physical depreciation? Their value depreciation can be quite different. Overall, we're going to be looking at depreciation by age for available comparables, because usually it's difficult to find sufficient comparables, at least for assets that are interesting to value, to be able to set a value immediately. And this means we have to be able to somehow connect comparables of different age, and so for that we need to be able to apply the appropriate understanding of depreciation through the appropriate depreciation table. For some purposes, depreciation profiles can be applied across asset types, and so it's not necessary to necessarily have a close understanding of the depreciation characteristics of each and every asset. This is particularly the case where you're doing plant and machinery valuation for financial reporting purposes, where you may have a large asset register composed of many items, each of which only has a relatively small value. What you'll be able to do there is be able to apply the character and behaviour of depreciation across asset types. For instance, you might decide that large amounts of maybe the office equipment has a particular working life and a particular depreciation profile, and you're able to then simply apply that perhaps to its historical cost with a couple of other assumptions to get a fairly good overall valuation. However, for more important individual assets, say for an excavator or a mining truck or something, that kind of general depreciation profile is probably inappropriate, and you'd want to have a more specific understanding of the character and behaviour of depreciation. To explore this question of depreciation character, I want now to consider a number of different possibilities in terms of the way that the price one would pay for an older asset may change over time. On the graph here is the first case I would like to consider. This is known in accounting terms as straight line depreciation, where an asset runs from 100% of its value down to zero over a period of time in an absolutely straight line. Each year, in this case, over 10 years, it's losing 10% of its value, and so by the time it gets to be 10 years old, the asset is worth nothing at all. This simple form of depreciation does actually apply to some assets, and it's good for us to think about perhaps what assets would follow a straight line depreciation schedule. A little reflection might come up with some things like candles or perhaps mines. In both of these cases, if I own a candle which is half used, then its value is the half which is not used, and so a straight line form of depreciation might be appropriate for the marketing of a second-hand candle. Likewise, mines have that kind of character as well, where there is some linear tendency that connects time or hours of use with the remaining value in a straight line fashion. This second trace, which is put up on the graph, shows an asset which falls off in value fairly rapidly from new, but once it gets down to a particular value, it sits at that value for a relatively longer time, maybe depreciating at a small amount, and then starts to fall off in value until it depreciates down to negligible value. What kind of an asset would suit this kind of depreciation schedule, this kind of a pattern or character or behaviour over time? Well, when we look at it, many tools have this kind of a character. In fact, many things that we buy. If it's sitting on the shelf in the shop, it will have a particular price. By the time we bring it away from the showroom, its value falls immediately, but then it only depreciates slowly in use until it gets close to the end of its working life, where again it starts to depreciate further. And so this kind of depreciation trend can apply to a number of things which are bought new. Move now to the yellow trace, which shows almost I won't say the opposite tendency, but rather from new, its rate of depreciation is very gentle at first, and it's only after a considerable amount of time that the rate of depreciation starts to accelerate. What kind of an asset does this? Its new value tends to remain for some time only very slightly depreciating, and it only starts to depreciate significantly by the time it's getting well into its economic life. Well, these kind of assets are often purpose-built assets, especially purpose-built plant in industrial situations. If a production line is built from scratch by a company, then its initial cost is not a showroom cost, but it's rather the cost of production. And that value will be reflected in that plant's ability to contribute to the company's profitability, which won't be very different over the first few years of its operation, while it's still new and fresh and operating with a relatively small amount of maintenance. As the plant ages, it will get to a point where the maintenance costs begin to increase simply because the production line or whatever it is now getting to be older, and so somewhere midway into its economic life, because its maintenance costs are increasing, its value, its contribution to the profitability of the business start to fall off fairly significantly, or at least at a faster rate. This fourth pale blue trace tends to do the opposite. It is subject to considerable depreciation as soon as you purchase it. What kind of assets have this kind of behaviour? Often new technology has this kind of character, especially if once you bring it home, very few people are going to want to buy a used item, whatever it is, because the item is going to be quickly made technologically redundant or obsolete. And so while it may be useful to you or your business, its resale value is relatively low. And so computers, laptops, those sort of things tend to follow this very rapid initial depreciation, followed by a relative flattening of the value. This is not to say that these assets are not contributing to the profitability of the organisation that own them. It's simply that their ability to raise a price on the open market is relatively low. The fifth asset we're considering is one that also has a showroom effect, an initial fall in value as a result of being brought away from the shop or the showroom. However, this one, it has a market plateau where once the asset is purchased, the value falls a little, but then it tends not to fall very much at all for a major part of its economic life. This kind of an asset is likely to be something, say, like a tool, a hammer, for instance. Something that you wouldn't pay the same for second-hand as new, but overall doesn't depreciate very much in terms of its utility value over much of its working life. And in fact, your hammer may retain pretty much full value until you've just about worn out its handle or something, or the head starts to come loose, which gets pretty close to the end of its working life, or maybe time for a bit of capital expenditure. And so the shoulder effect is a characteristic which can be an issue with certain types of plant and machinery, where the depreciation doesn't continue, but rather stalls for a fair period of time. Now we come to a case that has a rather peculiar characteristic of not simply depreciating downwards, but has what economists these days are often referring to as a J-curve form of depreciation. When we look at the characteristic of this asset, which is the purple trace, we see that its depreciation is fairly severe over maybe the first half of its economic life, where it falls down to a relatively low level, but then somehow its value bounces back, and in fact its depreciated value increases over time from then on. What kind of an asset displays this type of characteristic? Well, this kind of a characteristic is often what you see with a number of collectibles, especially collectible motor cars. An MGB, for instance, is probably one of the early classic open-top sports cars. And while British motor vehicles tend to have a fairly definite life expectancy, because the MGB was such a popular motor car, even though they depreciated for a few years after they came out of the showroom, they developed a real following as a collector's item, and so their value actually increased, partly because they were in limited supply and they were the kind of motor car that was so enjoyable to drive around that people didn't mind the extra maintenance costs in keeping them on the road. We now come to the seventh asset under consideration, and this one has an even more extraordinary depreciation character, where from new its value actually increases and continues to increase over a period of years until it reaches a peak. Thereafter, its value falls away. What kind of an asset could this represent? Well, in particular, one asset that has this kind of a characteristic is something which appreciates in value over time, but only to a certain point. Thereafter its value falls away. Now, collectible wine is probably the best example of an asset that has this rather peculiar depreciation character, because after the wine is bottled, its value actually increases over time as it approaches its optimum drinking age. And so in this case we're suggesting that might be 5 years after it's bottled. Wine buffs might disagree here, but at least conceptually they will get to a point where the bottle of wine will actually be past its optimum drinking date, and so from that time onwards its value will plateau and then start to depreciate. You don't necessarily want to pay a lot of money to buy and drink a bottle of vinegar. However, in practice, while wine conceptually has this character, and certainly its value does appreciate over the first few years after it's being bottled, we do find that there are collectible bottles of wine that are quite ancient and really appear never destined to be drunk, because they probably aren't so pleasant on the palate. However, because they're unique, very limited in supply, they do attract extraordinarily high values. And so we have to be a bit careful with the collectible wines here as to which ones we're looking at. With this consideration of the way that actual assets depreciate in practice, or at least we perceive them to depreciate, we can now look at the actual methods of depreciation that are used in practice. Most depreciation schedules and systems are done for taxation purposes. The aim there is usually for the financial advantage of maximising your early deductions by depreciating as heavily as possible, as early as possible. Ultimately, the question of depreciation is how to turn an asset with a finite life into an expense deduction as quickly as possible. Ultimately, it becomes a tussle between us and the Commissioner of Taxation, because the individual would like to turn our capital items into a depreciation expense as soon as possible, whereas the Commissioner would prefer us to keep our capital items as capital items and postpone the tax deduction as long as possible. By and large, the meeting point between both sides of this argument tend to have settled on the practical approach of reliance on a limited number of mathematical algorithms or characters of depreciation that are generally accepted, and there is a fair variety of depreciation schedules available now within Australian tax law. Ultimately, for fair market value, some kind of fair market depreciation is most appropriate when the valuation task is more than simply a routine write-down for taxation purposes. We've already seen that different assets have different depreciation profiles, and so for this reason we have to look at what mathematical algorithms best fit these different practical situations. The easiest mathematical model for depreciation is what is known as the straight line depreciation, which simply takes a constant fraction of the new price from the depreciated value of the asset each year until the asset has zero value. And so this is simply a matter of the annual depreciation divided by the economic life, and it's very easy to compute. Straight line depreciation suits things like mines and candles, as we've already noted. It also suits the valuation of land in the ancient Hebrew tradition of the Jubilee. However, it's some years since we've valued land this way. If we look at, say, a $100,000 asset with a 10-year life, it's only mental arithmetic to work out that we can depreciate that asset by $10,000 a year for 10 years to completely depreciate its capital value away. And so it's very, very easy to compute. The disadvantage with straight line depreciation is that it assumes that the value does fall in a uniform way. However, we've seen in the previous slides that for many assets there is a marked fall-off in value in the first few years. And this is the time when making a depreciation deduction would be most beneficial, when the dollars are most worthwhile. However, straight line depreciation fails to take account of this practical reality, and so in fact it gives us a worse deal than the market would in terms of recognising the pattern of prices. And for this reason, while it's simple and reliable to calculate, and hence relatively popular, it's not particularly financially ideal, and in many cases it doesn't mirror the actual value behaviour of the assets themselves. The second most common form is what's known as diminishing value depreciation. And this approach is also conceptually quite straightforward. Rather than taking a constant amount each year, it takes a constant percentage each year of the written down value of the previous year. This has the advantage that when we look at the graph, which is shown here in the blue trace, that at the beginning of the depreciation schedule, the rate of depreciation is somewhat faster than by straight line. And so for this reason, for taxation purposes, diminishing value depreciation is considerably more popular. It has the disadvantage, unfortunately, that it never completely amortizes the value of the asset. And this is because so long as there is a positive value in one year, from which some percentage will be taken to depreciate it the next year will always be a percentage of that positive value. In other words, it will continue as a positive number. Diminishing value depreciation is actually a form of exponential decay, and perceptive students will notice that the mathematics for diminishing value depreciation is very closely related to the discounting formula that is used quite widespread in finance. For practical purposes, because diminishing value depreciation works on the previous year's depreciated value, you can't simply use the same level of depreciation each year that might be applicable for straight line depreciation. For taxation purposes, a simple rule of thumb has been adopted, and that is that the allowable depreciation rate for diminishing value is 1.5 times the straight line depreciation, at least for taxation purposes. And so this gives us a nice rule of thumb. In the previous example, when we were looking at the $100,000 asset being depreciated over 10 years, that's effectively 1/10 of the new price being deducted each year. If the owner of that asset was using diminishing value depreciation for taxation purposes, they would subtract 15% of the depreciated value each year from that asset. And so while in the first few years 15% depreciation is considerably higher than 10, by the time the asset gets down in value towards the end of its economic life, the annual depreciation is somewhat less. However, this means that you are able to expense your capital expenditure, your capital value, a lot faster in the earlier years, which is quite effective. Although diminishing value depreciation does suit many assets, the problem in the latter part of the economic life of the asset with the method not taking out that last bit of value becomes quite a problem as an asset ages. For this reason, there are a number of other mathematical approaches to be able to give you a curve which hopefully would mirror the fall off in value more accurately. One of these, which is often cited, is known as the sum of the year's digits approach. This system is a mathematical, well, almost a mathematical curiosity that works by working out the depreciation for each year based on that year's relationship to the numerical sum of each one of the years of ownership. And this means that if an asset has a 10-year working life, you work out how much to depreciate it by comparing how old the property is compared to the sum of 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, the sum of the year's digits. And on the slide you can see the exact calculation that you use. The advantage of the sum of the year's digits approach is that it has an overall shape similar to the diminishing value curve. However, it exactly amortizes the capital value over the economic life. That is, in our example, over the 10 years, at the end, the remaining value of the asset is exactly zero by using this method. As a result of that, the sum of the year's digits is attractive as applicable to many situations which for taxation purposes might use the diminishing value approach. However, the intention, and it's arguably the case, that the asset has a close enough to zero resale value or salvage value at the end of its economic life.
The foregoing mathematical methods have been accepted largely for depreciation by accountants looking especially at their taxation obligations, and to a certain extent with an eye to keeping capital assets on the balance sheet in somewhere approaching a realistic estimate of their ongoing or current value. However, the plant and machinery valuer needs to be able to understand depreciation far more precisely than these simple mathematical approaches will afford. One way or another, if they're used at all, they have to be used in a way that is calibrated to the market. And so this means that depreciation for plant and machinery purposes has to be related in some way from known sales, from the behaviour of the market. In some cases, depreciation schedules and curves are constructed purely from known sales. Often this is the case where you have instances of sales of pieces of plant and machinery that have different ages to the subject, and what you need to do is somehow interpolate between the existing sales evidence and the subject asset. Often it's possible to derive insights regarding the character and behaviour of depreciation from other similar items. For instance, with respect to motor cars, we might be able to extend our understanding of depreciation, say from Holdens to Fords, if we don't have sufficient sales evidence of the subject. Although what we'll be looking at shortly will reveal that in some cases we have to be very careful that we are choosing genuinely comparable similar items. Overall, the object is to understand the market-derived depreciation for a given age of subject item. This means while we may have an academic interest in understanding the global depreciation behaviour of an asset as it ages, and perhaps different classes of assets, for a given valuation assignment we really only need the character of depreciation more or less in the vicinity of the ages of our subject assets, especially in terms of the ages of the comparable sales. Because we're only looking at a small part of the total economic life of the asset, this makes the project a lot more approachable. In practice, plant and machinery valuers use many different approaches, different mathematical equations to model or get a line of best fit between their comparable sales. And so we can move outside of the simple 2 or 3 that we've explored so far. However, we do find that even using them with a little bit of adjustment, we can get very good results very often without recourse to complex mathematical curves. There are 2 basic alternative methods to developing a depreciation schedule based on market evidence. The first is to compute using the subject's own, shall we say, historical new price. Now, the examples we've looked at so far work on this basis, and this is largely what an accountant will do when they're working out a depreciation adjustment on assets on a balance sheet. And the reason is that the historical new price is known, and therefore it gives us a nice solid reference point to work from. However, there are problems in practice with using historical new prices, especially when we're looking at trying to value a particular item given existing sales from other ages. And for this reason, it tends to be far more effective to compute your depreciation schedules and depreciation curves and so on, computed against current new price. And so that means if I have a 5-year-old Mercedes or something, I will consider its depreciation against the value, the new price of a Mercedes of a similar type. Now, this immediately presents a problem, because if I have a 5-year-old, say, motor car, it's likely that the makes and models will change, and so what was rolling off the showroom floor 5 years ago may simply not have a equivalent new car today, and that becomes one of the adjustments that we'll be looking at a little bit later. However, in general, by choosing the current new price of a comparable asset, hopefully as similar to the subject as possible, we're able to set up a single fixed reference for depreciation that we can then relate all of our sales to. And so you will find that while you can use the other method, working against current new price does tend to give you a stronger result than working against the subject's historical new price. There are exceptions to this, especially in the case of valuing large numbers of assets, say off an asset register. However, for cases where you are doing serious analysis of depreciation schedules for valuable assets, then we just about always use depreciation against the current new price. Let's now look at some practical issues in this depreciation fitting process. First of all, we've noticed that diminishing value is a strong model. It tends to suit, at least conceptually, the behaviour of many assets. However, there are a couple of irregularities that tend to make its simple application a little bit inaccurate. We've already noticed what I'm going to call the showroom effect, and that is the initial immediate drop from new value once an asset is taken out of the showroom. And so we're going to have to look for that effect in the data and also devise ways of dealing with it mathematically. The second is the question of residual value. Some assets do in fact depreciate in practice to the point where their scrap value is pretty close to, and in fact sometimes less than, their scrap or salvage value of simply unbolting them and taking them away to the dump. And so this means we have to look at how to put in the appropriate end point for our depreciation schedule. Sometimes assets will get to a point where while they only have a relatively low value compared to new, that low value tends to remain relatively constant for a very long time. It gets to a point where, so long as the asset is working, it has a kind of nominal residual value which makes it worth owning for the business, and in fact even worthwhile for somebody else to buy it to use. With productive assets, often an older asset is associated with extra maintenance costs, and while this is often the case, it's not always the case, and so again, familiarity with the market and the particular asset is very, very important. Lastly, the impact of technological redundancy is very important. Some assets do have this steep gradient of value decay, where even a relatively new and highly productive low maintenance asset will have a negligible market value simply because no one bothers to buy them second hand, because the technology is changing quickly, and also there can be a high level of suspicion in the marketplace about buying second-hand goods for certain assets. Computers used to be a good example of this kind of situation. Most businesses will only consider buying new PCs, and the reason for this is that you don't know what you're getting when you get a used one, and anyway the technology is changing, or has been changing in the past, so rapidly that an older item will be very problematic in terms of its ability to be able to be used effectively. I would now like to look at an example from a real market of how prices fall, to see if we can identify these lumps and bumps and general trends that we've been talking about theoretically. The market we're going to look at is the used car market. The advantage of looking at this market for our purposes is that it's a fairly deep market and a fairly well researched one. The data that we're going to be looking at in these slides all come from the Red Book. That is a book of used car values which is used by used car dealers and is also available for public access, and so it gives us a ready reference point. And while some people might be suspicious of Red Book car values, like Rawlinson's construction cost manual, it gives us a reference point to start with. On this graph we have plotted the depreciation behavior of a selection of motor cars. We've looked at a medium class Peugeot, a Mercedes, a Mazda 6 and 626 series, and the Ford Falcon. What we can see when we look at this graph is that overall it does tend to follow the general pattern predicted by the diminishing value mathematics, at least conformed to fit more or less the curve. And so we see that yes, diminishing value does work for motor cars. You will notice that our graph is constructed as used prices versus current new price, in conformity with what we discussed in the previous slide. Next we will notice that most of the cars we have taken all have an initial showroom effect, an initial loss of about 20%, or maybe somewhere between 15 and 20% depending on which one you look at. The Ford Falcon appears to have the greatest loss of value as soon as you roll it out of the showroom. When we look at the behavior over the first, say, 5 or 10 years, we see that some makes behave differently. Somehow it appears that the Mazda holds its value better than the other vehicles in the first 5 years of its life, but then it falls back down into line. Now, these figures were prepared in 2006, and while it's quite a complicated effort to extract the amount of data required for this plot from the Red Book, the learning that we can get from the 2006 figures still is sufficient to give us a good indication of the overall behaviour. The reason I mention that is that we're actually plotting two different makes or two different models of Mazda here, the 626 and the Mazda 6, and so this sharp fall might be attributed to the change in that middle range Mazda offering. We'll also notice that there is a shoulder effect evident, although not quite as evident as our initial discussion may have suggested. We see it with the behaviour of the Mercedes, say around 10 years old, where it seems that their values does plateau out for a time. The other main point to note from this graph is that over the very long period, all of the vehicles considered do tend to converge down to a residual that appears to be somewhere between about 5 and 10% of the current new price. That's fairly significant because while we were complaining that the diminishing value calculation always has some kind of a residual value, and in fact a residual value that for taxation purposes may be too high, in this case we see that the practical reality is that the diminishing value calculations actually underestimates the value of all of the vehicles under consideration from about 15 years onwards. And so you do have this strange phenomenon where once a car gets to about 15, maybe 20 years old, it doesn't seem to depreciate very much at all. That is the as long as it goes kind of value. And so we see that regardless of whether we're talking about a Mercedes or a Ford Falcon. Also on this slide we've included a plot which shows the same four vehicles with their values plotted against their historical new price. While the first 15 years or so, maybe even 20 years of the graph is quite comparable to our major graph, you'll notice that when we go into the older examples, we find that strange things start to happen. And this is largely because this particular graph catches the crazy period of extremely high inflation that was characteristic between about 1970 and 1990. And so the rapid rise in new car prices from about 1970 onwards is kind of caught in the peculiar way that these older cars, over 30 years old, actually appear to appreciate compared to their historic new price. And so you get to the extraordinary situation where if somebody was to have bought a Peugeot back about 35, 38 years ago, today it would still be worth something in excess of 60% of its historical new price, about 2/3 of its historical new price, which means that the thing really hasn't depreciated very much at all from its showroom value. Clearly, if we were trying to rely on some sort of a pattern against historical new price, this bump certainly able to be seen in the case of the Mercedes, but also with the other vehicles, especially the Ford Falcon, which is still for a 35 or 45-year-old model about 50% of its historical new price, means that the depreciation calculations become quite complicated and in fact almost impossible to work with in some systematic way. Looking further into the Red Book, we can find some other peculiarities of actual assets, and in particular we're going to look at special interest assets. Now, while we're looking at motor cars, which are personal toys, this also applies to a certain extent to certain productive assets used in business, especially in the electronics and telecommunications areas. In this graph we have added to the four cars that we originally plotted the Mazda MX-5, and you'll notice that while the MX-5 tends to hold its value a little better than a lot of the competition over its first few years as it ages. It tends to settle onto a residual value significantly higher than all of the other cars taken into account. And while we mentioned the shoulder effect with the Mercedes 280 series, you'll notice that the Mazda MX-5 holds its value somewhere in the vicinity of about a quarter of its current new price, regardless of whether it's 10, 15, 16 years old. And this means that you can buy one of these cars, maybe a 10-year-old one, hold it for 5 or 6 years, and sell it for virtually what you paid for it. In fact, because of the appreciation of the new car value over time, this analysis would suggest that you may even make a profit on it. Curiously, this is because this is a particular special interest type of vehicle. The MX-5 is an open-top sports car and has quite a specific following, and it has carved out quite a following in the marketplace, to the extent that it appears that their owners don't want to part with them. Now, we have to watch for this, because if we try to apply perhaps the characteristic depreciation of Mazdas in general to this particular part of the Mazda offering, we would find that our depreciation expectations were really quite wrong. And likewise, to use the behavior of the Mazda MX-5 to get some sort of an insight to what your Mercedes or your Peugeot or even your Ford Falcon were doing would again invite errors. And so what this means is that the plant machinery valuer must be cautious when making assumptions across asset types, even though they might appear to be similar, because often you do have these special interests where particular examples do have a characteristic depreciation or value profile which stands out from the crowd. We're now going to move to the practical question of modelling a depreciation curve to fit some data. We're going to take the example of the Ford Falcon. Now, the advantage of this particular motor car is that in Australia it is the model that has maintained its basic name and character for the longest period. And so we see in 2006 you would be able to buy a new Ford Falcon, but also one over 45 years old. And so this gives us a nice long market to be able to look at. If we apply the simple depreciated value formula to the Ford Falcon's behavior, we find initially that it does give a reasonable kind of global fit. If we take our spectacles off and stand back a bit, we can see that yes, the Ford Falcon has fallen away in a way which is broadly similar to the simple depreciated value formula. And so we have that formula as the depreciated value today equals the new cost times 1 minus the depreciation rate raised to the power of the year of age that we have. However, we also note that the curve, the mathematical depreciation diminishing value curve, underestimates the value of a very old Ford Falcon, but it overestimates the value of a relatively young one. And so we have these two errors between the market data and the mathematical curve. We can adjust our mathematics for the showroom effect by merely making an initial deduction up front for that initial showroom value loss. And we do that in the second equation, where the depreciated value is 1 minus our initial showroom effect, expressed as a percentage of current new price, multiplied by 1 minus the depreciation rate raised to the nth power, where n is the years of age. And we notice that by adding a 20% showroom effect, our curve now fits the behaviour of the Ford Falcons a lot better, certainly in the first 5 or 10 years of the vehicle's age. To accommodate the fact that as long as you have a Ford Falcon that is perhaps registerable, it will have some kind of base value, we're going to add a residual value component. And again, we're doing that as a percentage of the current new price, in this case about 3%. We do that by first of all removing the residual from the overall depreciation calculation using the diminishing value, and then we add in that percentage right at the end. And so the equation becomes depreciated value equals 1 minus the initial loss minus the residual allowance times 1 minus the depreciation percentage raised to the power of the years of age plus the residual. Now when we look at the pink trace, we see that our diminishing value curve follows the Ford Falcon quite closely. There are still a couple of lumps and bumps, especially around 8 or 9 years into the car's age. However, these are peculiarities that have to do with the dynamics of the market and the particular vehicle at that time. However, in general, we have quite a very good fit over probably about over 90% of the vehicle's history. And so we can see that with a couple of relatively simple adjustments to the straightforward diminishing value calculation, we're able to fit a curve very well to this asset over a period of ages spanning over 45 years. While we can see that we can apply mathematics to get fairly good curve fitting between theoretical mathematics and the actual market, there are some other practical problems that come up from time to time with fitting depreciation curves to particular assets. One which is particularly significant but relatively easy to overcome is the problem that happens when you don't have a current new price. And this is a kind of situation where, as a result of technological change, the asset, the piece of plant or equipment, is simply not available new anymore. This is particularly the case, say, with electronics and telecommunications equipment, where an asset even a couple of years old may have been so thoroughly superseded that even though it is quite productive and useful and well within its economic life, you can't buy the same asset for the same price and the same capacity. Today's items on sale might have a very different capacity, and their price might be quite different and perhaps even incomparable in terms of the package of what's available. How do we find a realistic market depreciation in these cases? Well, obviously we look for the market for resales of these assets wherever possible. But if we need to depreciate them, we can't depreciate them against the current new price because there isn't any. The way we overcome that is by escalating the original new price at an appropriate price index. Now, the most common price index that most people think of is the inflation rate, or the consumer price index. However, the Australian Bureau of Statistics also keeps more specialised price indexes or inflation rates for different situations. There are CPIs worked out for every state and capital city. There is also more detailed price indexes for specialised groups of items such as exports or imports and so on. And so the experienced valuer will select the appropriate price index for the type of assets they're looking at. There is a distinction in the way that you use escalators or inflation indexes that is worth pointing out. In common use, we tend to use the expressions inflation and CPI, or Consumer Price Index, interchangeably. However, while they're related, they relate to quite different things. Inflation is the percentage by which purchasing power changes from one year to another, usually downwards. The CPI, however, is expressed as an index number. So, for instance, the Consumer Price Index for a year might be 204 or 196 or some other number. It's not a percentage. But the way the indexes are used is that by getting a ratio between, say, the index today and the index as it stood 10 years ago, you get a ratio of the value of prices between those two periods. And so we use the indexes, we don't use the percentage change that we also get from the ABS. One problem with applying this method, that even though it's very simple, it's simply a matter of taking the original new price back in time, then you multiply that by the index today versus the index old, so the CPI in this year compared to the CPI maybe 10 years ago. And what this does is that it gives you a factor by which the original new price is escalated to present dollars. Doing that for some assets, it gives you quite a reasonable indication of what the new price today would be. When we check how it works in the case of our Ford Falcons that we've been looking at in the last few slides, we find that applying the prices new historically and then escalating them in this way seems to undervalue them, as we can see in the graph on the right hand side. In this graph you can see that if we escalate the new price that was paid for a Ford Falcon in 1985 up to 2006 values, we underestimate the current new price by about 15%. And in fact, that undervaluing of the new price happens whether it's a 1985 model we do it for, or a 1990 model, or even a 95 or a 98 model. And so we find that generally doing this method, applying this method to Ford Falcons, undervalues the current new price. Conversely, we can say that the current new price has increased in front of inflation or above inflation over this period. And so we can more or less see that in the behavior of the chart as the closer you get to the present time, or at least to 2006, the undervaluing effect tends to grow less. This suggests that you have to be wary of using this escalation approach to estimate the hypothetical current new price of an asset where it's not directly available, and this is exactly a caution that the valuer must heed. However, the valuer can develop a bit more confidence to its applicability by calibrating this calculation using other similar assets. And so if we were to perhaps escalate the value of the Ford Falcon by the way that maybe Holden Commodores have appreciated over the same period, then we would probably get a more reliable figure. Again, the market is always the best source of information for us to use. Overall, however, what we've found in this reflection on an actual plant and machinery or a chattels market is that we can apply mathematics fairly successfully to the analysis of the market and its interpretation. You can certainly use depreciation mathematics to get a realistic idea of what an old asset is worth in comparison to its current new price, and as we've seen in this present slide, we can even estimate what the current new price should be, even if it's not possible to get it. Overall, plant and machinery valuation can be considered as a specialisation within the valuation profession, and it should be treated as such. And so while we've introduced some general concepts, especially the importance of depreciation and some of its mathematics, valuers are cautioned not to attempt plant machinery valuation without adequate experience, and usually the best way to get that is by working with an experienced plant and machinery valuer. It's important for real estate valuers to have at least some sensitivity to the issues behind plant and machinery valuation. At the very least, it communicates a better understanding of the way that real estate values work, but it also gives the property valuer a better understanding of those items of plant and machinery that are likely to be tied up within specialist properties and so on. And so don't leave plant and machinery valuation completely outside the scope of your interest, because even if you don't actively become involved in it, it's still worth having a bit of a sensitivity for the way that it works and what it can tell you about those things that you do choose to do in your professional lives. On the other hand, adding plant and machinery valuation to one's skills is quite a valuable asset for one's careers, because by and large plant and machinery valuers tend to seem to work out with more profitable businesses than real estate valuers, but that might be just a chance characteristic of the professional market at this present moment.